All right, thanks for coming out. My name is Jason Williams. I'm with Microsoft Research AI, and I'm going to tell you about Project Conversation Learner. Project Conversation Learner is an AI-first way of building a task-oriented bot or conversational interface. At the heart of the approach is a recurrent neural network. It takes all the history of the conversation so far and uses that to directly predict the next action that the bot should take. This allows it to learn directly from examples of conversations, and that allows designers, business owners, call center workers to work in the space of example conversations to express what they want the system to do. At the same time, the approach is situated in code, so I can add constraints that govern when actions are available. So for example, if I'm building a banking system, I can have a constraint that says a user has to be logged in before they're allowed to transfer funds. And that's a relationship that I can express as a hard constraint. It's not a machine-learned relationship. I can also add APIs that go out to back-end services to gather information or to take actions in the real world. And the basic philosophy here is to code what it makes sense to code and to learn what it makes sense to learn. And I'm talking here about the dialogue manager, the dialogue controller that's choosing what actions to take next. Most of my time is going to be demonstrations of how all this works. But first, let me just kind of explain the workflow that you use to get started. When you get started, there is no data to train on, so we have to solve this cold start problem. And to do that, the developer starts off by playing the role of the user. So the developer types in what they think the user is going to say, and then in the UI, they choose what they want, how they want the bot to respond. So they go back and forth between playing the user and playing the part of the bot to interactively teach for the first maybe 10 or 20 dialogues or so. After they've done that, then they can deploy the bot. At first, this would be to probably friendly users, and then progressively more realistic and an open set of users. And in the UI, the developer can look at the conversations that are being logged, and where the system makes mistakes, they can easily fix those mistakes. And that's going to be one of the things I'm going to show you as well. And the point of this is this gets you from nothing to something to a good system, all the while you're improving the same underlying machine learning model. There's not sort of a dead-end path here of getting started and then having to transition over to some different model. It's the same machine learning model you're improving as you go. OK, so I'm going to show you two demos. In the first demo, this is going to be just sort of the basics of the functionality and the workflow and how this works. It's in the troubleshooting domain. It helps people reset their password. The second demo is going to pull in how you interface with code, how you extract entities, and how you add some of those relationships and constraints and business rules. So here is the Conversation Learner UI. These are the 5 different actions that I've defined for my bot. And again, this is helping people to reset their password. These are 3 different training conversations. And each of these conversations consists of what the user said, how the system should respond, then what the user said next, and so on. And so just to be clear here, when the model is predicting this last action, it's taking as input the whole of the conversation history before that. So it has sight of everything that's happened before that. That's the kind of machine learning that this is doing. So let me show you how this interactive teaching process works. So I have 3 example conversations in here so far. So the system knows something, but your expectation should be pretty low. So let's say a user comes along and says, I forgot my password. So I'm the developer, but I'm imagining what the user is likely to say. This entity extraction step, we'll come back to this in the second demo. This isn't going to be relevant for us the first pass through. Now what you'll see are the predictions from the neural network and their scores. So here, these are the different actions that the system has available. And these are all of the different scores there. And they're sorted by score. And you can see the network's pretty confident about its top prediction. And that's actually right. So this helps me to get a glimpse into what the network has learned so far and kind of guides my effort. I can see where it's certain and where it's uncertain. So I'll say, yeah, go ahead and take that action. I'll say that's for my local account. And now it wants to say, what version of Windows do you have? That's right. That's what it should do next. So now I'll introduce a path that it hasn't seen before. I'll say, well, what happens if the user says Windows 7? So here, if I look through this list, the action I want the system to take next doesn't exist yet. And that's fine. At any point, I can add another action. So I'll say, well, I want you to say how to reset your password on Windows 7. Now, when I create that, it will add it to the palette of actions that the system has, and it will go ahead and execute that action, and it takes it there. So I've now just expanded the set of things that the system's able to say. And every time that I provide another input like that, in the background, their neural network will go off and be retrained. So each time I get a prediction, I'm using the most recent neural network that I've created. So now I'm up to date. So now let me switch over and show what the end user would see. Right? So the end user doesn't see that whole teaching experience. They would just see an interface like this. And I'm going to intentionally show you the kinds of things that happen when you really deploy a bot. So one thing that might happen is at first people follow the flow you had in mind. So they might say, I lost my password. Let's say that's for my local account. What version of Windows do you have? Windows 10. So far, so good. This is the flow I had in mind. Now maybe a user says something like, thanks. Well, I hadn't anticipated that. Right? So that will get logged. We'll come back to that in just a second. I think I'm going to do a total of about 4 of these. So let's say I can't remember my password. Let's say Microsoft account. And then maybe the user says, thank you. And again, that's another case where as the designer, I hadn't anticipated that might happen. And that's sort of a moderate case. Then there's the more extreme case where perhaps people come along and they don't even know what your bot can do. They might say something like restaurants. And I have no good response to that right now. Or maybe they say something like driving directions. And again, I have no good response to that. This is exactly what happens when you deploy the bot. And the point of showing you this is now to show you how you can go in and very quickly learn from that and improve. So if I go in and look at this example of, let's say, the person says restaurants. Well, I can look at this and say, well, this is not what the system should have done. If I click on that, I can say, what should the system have done? Well, I need to add another action. I want the system to say, sorry, I can't help with that. That's going to be a new response. Add that to the list of responses. I can then choose it, and then it says, do you want to take and create a new training example from that? So this is now a new training example, which I could continue if I wanted to. I'm just going to leave that one there. Driving directions. Yeah, this isn't right. It should have said, sorry, I can't help with that. So there, and I've now created 2 more training examples. And then these 2, let's see here. Here, the system said thank you, or person said thank you. Well, this isn't right. And again, I want to add another response. I want it to say, you're welcome. Let's go ahead and take that. That looks good. And then I'll make this one last correction here. And here, yeah, that should say you're welcome. The point of showing you this is to illustrate that once you have these log conversations coming in, it's pretty quick to make these corrections. So now the neural network here in the background go off. That will get retrained. And now we can explore and see if we've really kind of got the beginnings of mastering those new behaviors. So before, I think I had restaurants and driving directions. Let's type in web search. Now, this is machine learning, so there's no guarantee we're going to get it right with only 2 examples. But here, yeah, that's the model's best prediction. It's never seen the term web search before, but there's also a word embedding model in here. So it has a concept of synonymy, and what it's learning is a boundary between what's in the task and everything that's outside the task. And with a few more examples, maybe 5 or 10, those scores would increase in certainty dramatically. So I can say, sorry, I can't help with that. Now what happens if I continue this and I say, I lost my password. So here you can see the conversation here has gotten back on track, even though we've never seen a flow quite like this before. Let's say that's for my local account. And which version of Windows do you have? Yeah, so far, so good. And let's say now we were to say, I don't know, Windows 8. And I don't think we've ever seen this flow before either. And now let's say if the user were to say thanks, Let's see if we can pick up if we've got the beginnings of that behavior, and it looks like we've got the beginnings of that one too. So now if you look at this, we've never seen a flow that stitched together these transitions before. I didn't have to code that. That's the benefit of using machine learning. It's able to look at bits of conversations it's seen before and infer what the right path should be. And if it doesn't get it right, you can make corrections. OK, so that is sort of just the basics of actions, this prediction model, and how, when user data comes in, how you can make corrections. I want to switch over now and show you more of kind of the depth of what's here and how you interface this with code and with business logic. And to do that, I'm going to introduce the whole event loop. You've seen just a part of that so far. So when the user types in, for example, what's the weather in Seattle, that first gets passed to an entity extraction. That looks for substrings that you define. So here, Seattle, for example, would be an instance of a city, and I can label for that, and I can learn that entity. That then goes to code that you define, if you wish to, where you can do processing on those entities. So here, what I might want to do is I might want to take Seattle and look it up in my database and see, can I produce a weather forecast for Seattle? Do I know its latitude and longitude, that sort of thing. That then goes to the neural network that does prediction. That part you did see before. So these are the different actions and the scores that come out. If there are constraints on actions, then those can be clamped to 0. So you can see some of the actions here have been forced to 0. In the demo, I'll show how that happens. Then you go and execute the action. That action can be an API call. API calls can go off and look up information, for example, retrieve a weather forecast or transfer money in people's bank accounts, whatever makes sense in your domain. They can also return text back to the user. They can also generate a card and return a card to the user. You can chain actions together. So after taking one action, I can say, all right, go and take another action. You see the scores on the right updated in red. Then you can execute a second action. So this whole event loop runs until the last action, and you wait for user input. So let me show you what that looks like in a different domain. This one is in the pizza ordering domain. So in the last demo, there were no entities. And in this demo, I do have some entities. So here I have toppings. That's going to accumulate pizza toppings. And there's some sophistication here. It can accumulate more than one. And also, they're negatable, which is going to let me add and remove toppings if I change my mind. You'll see how that works. The other two entities are not things that we recognize from the user, but they're things that the system can populate and then output. So this gives you a way of parameterizing actions. So you can have a small number of actions, and then you can set values in code. Here are the set of actions here. So some of them are pretty simple. What would you like on your pizza? Other ones include references to entities. So for example, you have $ toppings on your pizza. Actions can also have constraints. So here, this action, you have toppings on your pizza. This has a required entity of toppings. And what that means is that in order to take this action, that entity has to be defined. And vice versa here, what would you like on your pizza? That has toppings as a disqualifying entity. That's a way of saying if that entity is defined, then you're not allowed to take that action. This is a way of saying don't ask for something if you already know it. Actions can also be cards. So this is an example of a card. Would you like last toppings? That's parameterized, and then the user can click yes or no. Finally, actions can also be API calls. So here I have two API calls. For example, this first one is the one that will actually go and send the pizza to the person. So there are, I think, 6 training dialogues in here. I'm just going to go ahead and step through one of these and show you how this works. So let's say the person says, order a pizza with mushrooms and cheese. So this goes off to the entity extraction model. When that comes back, the entity extraction model has predicted that mushrooms and cheese are examples of toppings, and that's from the training examples I've given it so far. If these were not correct, I can fix them. Entities can span multiple words. Here, it got it correct, so I'll leave it as it was. So when I go and score that now, you're going to see a couple things happen. Those toppings are now present in the bot's memory. And those will get persisted for the conversation. And I'm going to be able to manipulate those in code, too, if I want to. That's just the default behavior. Now, its prediction here is you have $ toppings on your pizza, and that's right. But you can see here there are a bunch of actions which are disqualified, which we're not allowed to take, and those are because of those constraints. So this is the effect of those those constraints, which here are encoding common sense, but also can encode business rules as well. So you have $ toppings on your pizza. That's right. Now that action had a property which made it not a wait action. So that one does not wait for user input. So that means that then the system can take another action. Would you like anything else? That's right. That's also what it should do. So this gives you the ability for the bot to take multiple actions in a row. Now let's say this is, I had forgotten some people that I'm with here. They don't like mushrooms. So I want to remove mushrooms and add peppers. So here, I don't know if you can see it there okay, but there's actually a minus before that toppings. That's saying to remove toppings. And add peppers, that's plus toppings. So this is a way of being able to both add and remove things from this list that's being accumulated. So that's right. And you'll see here the effect of that in the bot's memory. It still has cheese from before. Peppers is in bold because I added it. Mushrooms is in strike through because I removed it. So you have toppings on your pizza. That's what the bot should take next. That's good. Would you like anything else? Now I'm going to show an example of something that this pizza place doesn't have, which is yam. And that gets flagged, that gets marked as a toppings entity, which is right. But now the effect of that entity detection callback is that it shows up here in out of stock. And this is an example of how you can add code to be manipulating entities. So I'll show that to you here. I think that's just big enough. So this function here, this entity detection callback, every time after that entity extraction step runs, this event handler runs. You can then go in and manipulate the entities however you want to. And what this does is it grabs the toppings that were recognized, steps through them, checks to see if they're in stock or not. Using this stubbed out function here, these are the set of toppings that are available in my pizza place. This would, in a real system, this would be dynamically looking up like what the specials are this week or whatever. And then if something is not in stock, it takes it out of this toppings entity and puts it into this out of stock entity. So that's what just happened. This is the code that's running locally for this bot. And then that allows a new set of actions to be taken. One of them here is this, we don't have out of stock, which is what it should do. Would you like anything else? That's what it should do next. And then I can say no. And one difference here with an approach where you might be labeling intents is that this no I might label as an intent, which is the sort of no class of things. And then I'd have code that would figure out what action to take next. But in this approach, you just choose directly which action you want the system to take next. So you don't have to be aware of as much of kind of the dialogue control logic. You just choose what you want the system to do next. So here, finalize order, that's that API call. That says your order is on its way. And let me just show you quickly how you can register those API calls. So here, this finalize order, what that does is some entity manipulation, and then it returns the string your order is on its way. It could have also returned a card. Speaking of cards, let me just show one last step here. Let's say the person comes back and says, order another pizza. So the action there is going to be this prompt. And here I want to really guide the person toward a yes or no answer. And so this is, would you like cheese and peppers? That's what I had on my pizza before. And this is strongly guiding me toward saying yes or no. If I click on yes, that just comes back through as a string as if the person typed it in, and then the conversation would continue from there. So this demonstration illustrates how you can add entities, how you can add logic that constrains when actions are available, and how you can wire all this up to code. But at the core of this, the selection of what action is happening next, that's being driven by this recurrent neural network. So to summarize, Project Conversation Learner is an AI-first way of building a task-oriented bot. It combines a recurrent neural network with business rules and common sense that you express in code. And this is all built on top of the Bot Builder v4, which means that this bot is, you deploy in the same way to all the different channels that the bot framework supports. So this bot can be readily deployed to a web page or to Skype or to Facebook Messenger or any of the other channels that, as a Cortana skill, any of the other channels that the bot framework supports. It's released as of this morning as a by invitation Labs cognitive service. You can go to the link here to request an invitation. And we're really excited for your feedback. Really looking forward to seeing what you'll be able to build. Let me just show one other thing, and then I'll come back to this if anyone else wants to grab that URL. I just want to point out that there are a number of conversational AI sessions at Build. This is one of them, the one that's highlighted. There are, I think, 3 more theater sessions today, and then there are some breakout sessions and another theater session tomorrow. I'll put this back up in case anyone wants to grab that URL. Super. Thank you very much.